In this example, we have a more complicated function. It has many things going on, and we're going to discover each one. The first thing I notice is that there is a reflection. Because there's a negative outside the function, I know that this reflection is a reflection across the x-axis. Inside the parentheses, I see that there's a 3 and there's a 9. I can't read this information the way it stands. In order for me to detect horizontal shifting, I need to have x alone. So this tells me that I'm going to need to factor this expression so that I can see how many units I move to the right or left. And lastly, I have a vertical shift or vertical movement of 3 units. And since it's a plus, that means it's going to go up 3 units. Okay, before we start, let me say that we're going to work this function in a certain order. The very last thing we're going to do is go up or down. So don't worry about that right now. Now, here I have a reflection and I also have a movement left or right. Before you move left or right, make sure you have reflected first, okay? Otherwise, your end result will not be correct. So keep that in mind. Do not move right or left before you have reflected. So reflection needs to go before moving left or right. We can compress or stretch before reflecting. That's not a problem. But we cannot move left or right before we reflect. Okay? Okay. So let's work with this parentheses here. I was saying that in order for me to know if I'm moving left or right and how many units, I need to factor this expression. So that means leave x alone. So if 3 is in front of x, that means take the 3, pull it outside of the parentheses, and then inside the parentheses, you use distributive property backwards. You want to end up with the equivalent function. So 3 times what will give me 3x? That would be an x, right? If I multiply 3 times x, I will get back this term. Then I have a minus, so minus. And then 3 times what will give me back negative 9. So when I multiply 3 times whatever number I write here, I should get back negative 9, so that would be 3. So let's check again. 3 times x, 3x. 3 times negative 3, negative 9. That means that this is equivalent to this. Now x is alone, and I can see that it's x minus 3. That means I will move 3 units to the right. Initially, this looked like a movement of 9 units to the right, but don't be deceived. I cannot read the information when x is not alone. Okay? So I'm going to rewrite this function as f of x is equal to negative parentheses 3 parentheses x minus 3 close parentheses, everything is raised to the second power plus 3. And this is the function that we will be working with, which is equivalent to the original one. Okay, let's look at the function and describe what is happening. The first thing I see is there's a reflection across the x-axis. There's a 3 inside of the function. How do I know it's inside? Because the 3 is being squared along with the x minus 3 term. So there's a 3 inside. This 3 is a number that's greater than 1. Automatically, I know that this is a horizontal compression by a factor of 1 over this number, by a factor of a third. I also have a horizontal movement of 3 units to the right, and I also have a vertical shift of 3 units up. Okay, so I'm going to describe that in words. Here's my description in words. The parent function, and I write my parent function, and I left these blanks because this is the important thing that we're going to fill out. The parent function x squared has been reflected across the x-axis, so we have to be specific across what axis, horizontally compressed by a factor of 1 over 3, horizontally moved, and we had said that it was going to move 3 units because we had factored this inside the parentheses. 3 units where? To the right. When there's a minus inside of the function, it's a movement to the right. And vertically moved 3 units, 3 units, and this should say up. And there you go. Here's the description, okay? So let's go back to that function that we factored. Okay, here's my factored function, and let's start selecting some points for the parent function. So when x is 0 in the squaring function, y will be 0. When x is 1, y will also be 1. When x is 2, I get 2 squared, which is 4. And when x is 3, I get 3 squared, which is 9. Okay, I think that's enough points. That'll fit on my graph. And let's plot these coordinates. So I have 0, 0, 1, 1, 2, 4, and 3, 9. This parent function is an even function, which means that it's symmetrical with respect to the y-axis. Therefore, all of these points that I plotted, I can map across the y-axis. Okay. Now I can sketch my parent function. There's the parent function. Now I'm going to start working with my new coordinates. I'm going to multiply each one of the x coordinates by 1 over this number. So that would be 1 over 3. So that's going to be by how much this function will compress. 0 times 1/3 is 0. And remember, your y values will stay exactly the same. 1 times 1/3, 1/3. 2 times 1/3 is 2/3. And 3 times 1/3 is 1. So these are my new points. Let's plot them. 0, 0, 1/3, 1. That means go a third over and up 1, about here. 2/3, 4, go 2/3 over and up 4, so about here, right there. And 1, 9, go 1 over and up to 9. Okay, notice how this function has been compressed. It has come closer to the y-axis. This x value has shifted over this way by a third. Over here, it is compressed by a third, and this number has compressed over by a third. And again, we mirror these values to the other side because the same values exist on the other side. So here's this one. The next one is right here at negative 2/3, 4, and then negative 1, 9. So here's the compression. Okay, now I start doing the rest of what this function says. The first thing I'm going to do, remember, before I work with this movement to the right 3 units, I'm going to go ahead and reflect first. Okay, remember, always reflect before you move to the left or right. So when I reflect, I take these values that I have here and I'm going to reflect them across the x-axis. That means all of these values will end up down here because I'm folding this paper across the x-axis. So 0, 0, when you reflect, it stays in the same spot. A third 1, since I'm reflecting across the x-axis, the coordinate changes its sign to its opposite value. So I will have a third negative 1. So the same point that's at 1/3 1 reflected here. And I will also have the other side because this is an even function. The second point, which is 2/3 4, I go over 2/3 and I go down 4 because I'm reflecting. So about here. And its twin over on the other side, okay? And the last point is 1, 9. When I reflect that one, I'm going to go over 1 and 9 there. And that same value on the other side. So there's my reflection, okay? And you can dash these lines or not, because now I'm going to move each one of these points 3 units to the right. So I'm not going to dash them yet. So I'm going to move the origin 3 units to the right. Just count 3 over. 1, 2, 3. Here's the new vertex. And then I move this one over 3. This is a third over, so 1, 2, 3, about here. This point here, let's move it 3 over. So 1, 2, 3, about here. Same thing here, 1, 2, 3. And this one also, 1, 2, 3, right there. Notice that the reflection or the symmetry remains. This is a map of this, and this is a copy of that. And move this one 3 over, 1, 2, 3, down here about, and 1, 2, 3, right there. So I moved it 3 over. Each of these points I moved over 3, and I still have something left to do. I have to go up 3. So I'm still not going to dash this line. I'm just going to move each of these points up 3. So I'm going to start with the vertex 1, 2, 3. The next point, this one goes up 3, right here. And then its map, which is right there. And its map, which is about here, goes up 3. This one goes up 3, 1, 2, 3, about this much. And this one goes up 3, 1, 2, 3. And then these that are down here up 3, 1, 2, 3, right here, and 1, 2, 3. Okay, I've moved all of them up 3 units, and now I can draw my solid line because this is my final graph, and this is how it looks. And we label f of x. You can use your original function to label this. You can also check your work using Desmos. If you want to check with Desmos, there are some key points that you should check. This vertex, if I look for that coordinate, so here's 3, 3. And I also have this coordinate here and here. One of them is 2, negative 6, and this one is 4, negative 6. So I can check these 3 coordinates with Desmos to make sure that my graph is correct. Here's Desmos. Here's my graph. Notice that this point is 3, 3, which is one that we had. And also, let's check the ones down here at 2, negative 6. Here it is, right there. 2, negative 6, and 4, negative 6. So it checks out. That means that our graph is correct.